Hi guys, what I wanted to show you today is a demo of the proof of balance for Orchard. So the code is available on GitHub in this repository. I should add a README. It's not there yet. I would find a README after video. All right. So the idea here is that you can show that you are in control of a certain number of coins of deck. Up to a certain height. So that height is the snapshot height. And if you have coins acquired after that height, they don't count. And if you spend coins after that height, it doesn't matter. The new parameter that is added to this proof of balance is the start height. So with the start height, the idea here is that if you have coins that were acquired before that start height, they don't count either. So this is actually more like a range that you need to have coins in. And the good thing about having a range instead of having just a snapshot height is that we can bypass the spam period. So if you are doing that as a test, you can quickly make a proof because you don't have to download the entire blockchain. You just have to download blocks that are inside this particular range that you decide. So obviously you can have a range that starts at the activation height, but you can also have a start height that is way later, any time after activation height. So what I've done here, okay, so let's start by cloning the repo and doing that from scratch. I'm gonna create a temp directory and clone from there. Okay, and go to that thing and do a Cardo build in Ready. The other stuff with this Orchard proof of balance is that, of course, it has to be Orchard. You cannot use transparent or sapling coins. But the advantage is that first, it's fully shielded. You will not reveal your nodes or when you acquire them, your address. You just reveal your balance that you are proving. And also, you can do simultaneous proof of balances because there's a domain, and if we use that to and we associate information with the proof of balance, then we can have a voting system, a coin voting system, or airdrop, or many other applications. And when you do that, then the election of the purpose of the proof of balance becomes the domain of the proof. And if you have different domain, then the information is unlinkable. So that was an improvement, a major improvement, I would say, compared to a solution where you're revealing the nullifier, directly the nullifier. And that's also why this is really working with Orchard and not with Sapling, because this requires changes in the circuit. It kind of required some new rules in the circuit. So this is kind of a different circuit. Many of the things are uncommon, of course. We use the same validation as in Orchard, but we have added some new rules. Okay, so that's done, and now we can run the code. So let me show you the parameters of this particular election. You have a URL, which is the website is doing the election, and inside that particular website, you can run multiple elections. So this is the name of that particular election. The start height is what I said earlier, is the first block where we accept coins. If you have received coins in that particular block, they are eligible. And the snapshot height is the block at which we end the proof of balance. So if you have received points in that particular snapshot height, they're also eligible. So it's inclusive and inclusive. The rest is you can safely ignore for the moment. All right, so we have these parameters, and now we run the program. Rango run. So now we can do help, the commands of these tools, The first step is to download the blockchain. So we do download, and we have to put the URL of Light Wallet D. I'm gonna use one of these guys. You can use any Light Wallet D, including your own, of course. This will download this particular range of blocks. So that shouldn't take too long. Download. Okay. And now we build the reference data, which essentially creates the Merkle trees. With that few blocks, that shouldn't be too bad either. Right? It's pretty fast. And we are ready to create the proof. To create the proof, you need a wallet. Obviously you need to have some coins under your control. So I need to create DirectoryDB and copy the database file from Zeek Wallet. I put a sample database in my TMP directory, so I'm just going to copy it there, and then we run the tool. Now I can do a create proof, specify a file name, so let's say proof.bin, and the wallet account number. This wallet has 2 accounts. I'm using the second one, and it's calculating the proof. This particular wallet has 3 nodes, so he's going to do it 3 times. Second node, and now the third node. You have to check that the CMX anchor and an NF anchor are always the same. If they are not the same, it means that something went wrong. And this information here is then put into the election file. So these guys here, they should be the same as what we have in the configuration file. So this is the same as this guy here, and the NF root is the same as this guy. Yeah. Okay, so now we have a proof, which is proof.bin. I can delete the data. I don't need the database file, and I don't need the data file. So I would delete both directories. And if I'm the guy who receives these proofs, so I'm running this now from the point of view of the election board. I just want to verify that these proofs are correct. I do verify proof with proof.bin. I expect the proof to check out. So the ZK proof was verified for the first node. Then same thing and then the pending signature is verified. And we do it 3 times, 1 for each node. And finally, the binding signature verifies that the total balance of these 3 nodes sum up properly. And we have checked that we are actually essentially the sender was in control of 0.4797 ZEC. So that's it. You can see that it's fairly easy to do a proof of balance this way. Of course, there's more work. The logistics of sending, receiving these files, creating receipts, or the workflow is not implemented, as well as the check that the person who sends you the proof is not sending you twice the same proof, the same coins. We're using the same coins, but that is very easy because each node has a unique nullifier that is only valid for this particular domain of proof of balance. So if he tries to use the same coin twice, he will have to submit the same information, the same nullifier. That nullifier is going to be different even if he reuses this coin for a different domain, different election. But for the same election, he will be forced to deliver the same nullifier. This nullifier is scoped to the election. All right, that's it. If you want to read the code is available on this repository, and it's linked to a particular version of Orchard. So you also have to go to Orchard, my Orchard repo, one here, and check out this particular revision, because this is the one that has the domain nullifier code.